right, so let's try out an example of the chi-square test for independence. This is on marital status and drinking. So a national survey was conducted to obtain information on the alcohol consumption patterns of U.S. adults based on their marital status. Okay, so we got a random sample of 1,772 residents. So let me fix this typo here at the bottom. And at the 5% significance level, do the data provide sufficient evidence to conclude that an association exists between marital status and alcohol consumption? All right, so the P and phantoms are being asked to test the claim that there is some sort of association between marital status and alcohol consumption. Okay, so that means my null hypothesis is going to be that marital status and alcohol are independent, and my alternative is that they are dependent or not independent. So we have some assumptions and conditions here. So we need a simple random sample, and then we need all of our expected counts to be greater than 1 and at least 80% to be 5+. All right, so to get started on this, we were told that we have a random sample. So we can check that off. And then to get started on the expected values, remember the formula for that is going to be E is equal to RC over N. So where R is the row total and C is the column total. So for this box here, single people who don't drink alcohol, my row total is 354. My column total is 590. And I'll divide by the total sample size, which is 1,772. And that gets me about 117.9. If I did this one here, so this would be people who are widowed who drink 1 to 60 drinks per month. My row total is 143. My column total is 957. And so I'll divide by the 1772, and that gets me approximately 77.2 people. So go ahead and give this a try. If you did this in preparation for class, and you can just keep watching. Otherwise, I would like you to go through and at least do maybe half of them to really get a good sense of how this works out. So all right, so let me put the numbers that I got up here. So here's kind of what I found. I'm kind of looking through these numbers. I don't see, the smallest one I see is a 13 here. So they're certainly all greater than 1 and also all greater than 5. So I can check off these last two assumptions and conditions here. And then the name of my test. So I have the 2 categorical variables and I've met this criteria. So that means the test I'm working on is a chi-square test for independence. And then to get our test statistic, what I need to do is I need to calculate for each box up here, so all 12 of these, I need to calculate that observed minus the expected squared over the expected, and then I need to add all of those up. Okay, so that'll give me my chi-squared test statistic. So let's switch over to Excel and we'll look and see if there's a faster way to get these expected values, and then we'll work on getting this test statistic. So give me a second and we'll switch over. All right, so here's our spreadsheet for marital status and drinking, and you'll notice that I filled in the box for all the observed values. Okay, and then I want to work on this expected one. So there's a little bit, we can take advantage of some copy and paste here, but we got to be careful in how we do that. So I generally like to do my copy and paste going down. And so this box here I know is going to be equal to my row total. And then I need to multiply by my column total, which is the 590. And if I think about all of these boxes in this abstain column, all of them are going to be multiplied by the 590. So I'm actually going to type the number 590 in there rather than clicking on the box that has it. And then I'm going to divide by the 1772. Okay, and also since that's a fixed number that's not going to change for any of these, I'm going to just type that in there. Okay, and the reason that I only have the one cell that is listed as E10 is because if I made all of those so that they were the box that I clicked on, then when I copied it going down, the 590 would change to a box that's 0 because it would be the box right below it, as with the 1772. So to make sure that that doesn't happen, this is one way you can get around that. There's another way of putting dollar signs in front of the E and the 10 and stuff that would also do that, but this is probably the easiest. So I have the row total clicked as E10 times 590 divided by 1772. And then I can copy and paste that all the way down. And then if I look at the column for the 1 to 60 drinks, I can do equals and click on the row total. And then again, those are all going to have that same column total, the 957. So I'll just type it in and divide by the 1772. And then I will copy and paste that all the way down. And then I'll do the same thing for the 60 plus drinks here. And copy and paste it all the way down. Okay, and so I have all of my expected counts. And now at this point, if all I need is a p-value, so if I'm not trying to figure out the test statistic, I can use the chi-squared test command. So that's the CHISQ.test. And it's going to ask you to highlight your actual or your observed range. Then it's going to ask you to highlight your expected range. And then we'll say, okay. Oh, must have gotten off a little bit here. Oh, I forgot my comma. Let me fix that. So there's my observed, put a comma. Here's my expected. There we go. Wow, so super tiny p-value. So that's great. But now if I wanted to get my test statistic, I need to calculate that observed minus the expected, square it, divide by the expected. So I'm going to come down to this last set of boxes I have, and I'll do equals and open a parentheses. Then I'm going to click on the corresponding observed box minus the corresponding expected box. And then I will put an up caret and square it, and then divide by the expected box. Okay, so there's the first piece that's going to become part of my test statistic. And I'm going to copy and paste that going across, and then just copy and paste it going down. So I get all 12 of those. Okay, and all I need to do now to get my test statistic is add all 12 of those up. So I'll do equals the sum. I'll highlight these guys. So there's my test statistic. Wow, it's a really big test statistic, 94. And then to get my p-value, I can always get a p-value by looking up the probability from the distribution. So equals a chi-squared.dis.right. And it asks me first for my test statistic. So I'll click on that box. I'll put a comment, and then it wants my degrees of freedom. So to get the degrees of freedom for this particular test, you're going to take your number of rows and subtract 1. So I have 4 rows. If I subtract 1, I get 3. And then I'll take my number of columns and subtract 1. So I have 3 columns, subtract 1 gives me 2. And then I multiply those two numbers together. So 3 times 2, so that tells me my degrees of freedom are 6. Okay, and then I get the exact same p-value, which is as it should be. So I'm going to go ahead and put both of these down on my paper, and then we are going to switch back and finish up writing this guy. So P is 3.9 times 10 to the negative 18. Wow. All right, so I have my chi-squared test statistic and my p-value, and our alpha here is 5%. So let me compare that p-value to the 5%. And we see that P is definitely much smaller than alpha, which means that I do reject my null hypothesis. And so my conclusion statement is going to be with P equal to 3.9 times 10 to the negative 18, at the 5% significance level, we do have sufficient evidence that marital status and alcohol consumption are associated or are dependent. That would also work fine. Okay, so there's my conclusion statement. So again, we're just saying that these two things are related. We have not shown a cause and effect here. So you can't look at this and take the highest number and say, oh, if you're in this category, it means you're going to have to start drinking or anything like that. So there's not a cause and effect, but there is a relationship here. So it's shown that marital status and alcohol consumption are associated based on this data.